really is a lot of the keys for the exam. We're still going to do an exam review, but I wanted to use today's lecture to really get into all of what you need to know. We've spent the last couple of virtual lectures going over some commands, and I wanted to really specifically call out the basic ones because you need to know these for the exam and for what they mean. So going through, we spent a lot of time on create, specifically around the tables. What I want to make sure that you've got a good understanding, a keen understanding of, is also insert. Getting values into your tables. What if you have tables with no data, they're really worthless for you. Select is where we fit you with the select from where. Deleting removes the data, update modifies it, and drop destroys. Try not to get delete and drop confused. The drop will completely destroy the data, where delete is just going to remove specific data within your table. So let's look at the form of the create statement, because in the exam you're going to see a number of different ways that I've gone about doing this. Specifically, I'm looking at the create table and then how you're having both the table name and then the column name and data type attributes. The key from a naming perspective that you need to look at is you need to make sure that you don't use reserved words like table, create, drop, destroy, etc. as the table names. Similarly, the generic form for the insert statement is going to follow an insert into. So where you see the create table, you're going to see insert into table. Obviously, the table needs to be created first before you can insert into it. So as an example, if I'm inserting a record into the contacts table, first I'm identifying the columns that I'm going to be, and the fields I'm going to be inserting information to in the table. So in this case, I'm going to be inserting into contact ID, into name, into address, etc. Specifically the column value. So if you look at this, you'll see ones for the numerics, and then you'll see some single quotes around the text items that are coming. Those are for items that you're putting in as text and something that you're not looking to do any mathematical calculations on. So if I'm looking at a partial record, you can excuse me, insert into contacts the contact name and phone number, as well as in the values that you're looking to add. Moving on to review of select. From a generic perspective, look at this from the order. You see this, and I've hit it a couple of times already. You're looking at select, from, and where it's always going to be column, table, and condition, and then you start getting into how you're dealing with the results. So you're going to have group by, having, and order by. So you're always going to see group by ahead of having. You'll never see having and then a group by. You can have having without a group by, but you need to look at it from an overall order perspective. So it's the most commonly used piece of SQL over and over and over again. It's what you're really going to see in the exam. But it makes it important to read what you're looking at and what you're trying to do. So going back over select statement, for the select and the overall, if I'm seeing an asterisk, I'm selecting all. So if I'm doing the select asterisk from contacts, it's going to display all records. Now I can then specify down to a different level if I want to get just the contact ID or the name, in which case I would do a select contact ID and name from contacts, or if I want to select distinct variables, distinct data within a table. When I get into where it really helps you refine what you're doing and what you're pulling, so it allows you to start doing conditional expressions. So if I want to, select all from administrators where last name equals Finnegan, or select all from contacts where age is less than 10. It'll allow me to do that and more fine-tune the data that I'm storing. We've covered like as well. From a like perspective, what we're really looking at is allowing you to do a comparison of strings. So essentially, if I want to find all tables where instructor's last name begins with F or where last name starts with J, this is how you would do the statement. You would have in the single quotes the J, and then you would have the percent sign. So if I wanted to do, let's say, if you know the last person's name is Jones, and you want it to be that starts with J-O, you would see the J and the O, and then the percentage sign. Similarly, you can do it for an ending. So if you want to find out which tables in the field are website addresses, you can do a select all from contacts, or the URL, and then .com. So as I mentioned with delete, delete will remove data from the tables. Again, this is different from drop. So you're going to do a condition in the where. So a good example, if I want to delete from contacts all contacts where age is less than 13, this is how I would write that SQL statement. Again, look at the top and then the bottom so you can understand what it's doing. So delete from contacts where age is less than 13. What I would do when I'm studying, excuse me, when I'm studying is to go through and just look at some of these SQL and just write them down in plain English. It'll help you from a multiple choice perspective. If I'm going to do a modification, I'm going to use update. Again, it's the same scenario as delete. I'm going to update, I'm going to do the table, and then I'm going to set what the new item is and the condition that occurs. So if I want to change companies' names from AOL to Time Warner, if I want to change stadium names in Baltimore from First Marin Arena to Royal Farms Arena, this is how I would go about doing the SQL. If I'm going in to do a drop, again, it is going to completely destroy the table. It goes away, it's not recoverable. It's not something that we can go back a few minutes later and say, hey, I want to restore this. Once you're doing a drop, unless it's backed up somewhere, it's dropped for good. Now I'm going to spend a little bit more time talking about the select statement again. So let's look at this from a join. If we've got phone numbers, addresses, and people, I'm going to select the name, phone number, and zip from people, phone numbers, and address, where the people address ID equals the address ID, and the people ID equals the phone ID. This is a very common type of SQL, okay? It's going to be looking for commonalities and tying information together. You're not just doing SQL off of one table. You're going to be pulling things. It's why it gets key into understanding primary and foreign keys to essentially help you connect the dots. Now, that being said, there's a lot of different types of joins. We've spent most of our time in the lectures on the inner joins, and I want to make sure that you understand all of them and what that means. So if I'm talking about an inner join, I'm looking at unmatched rows in either table that aren't printed. If I'm doing a left outer, it's all records from the left, and this will make sense in a few minutes. If I'm doing a right, it's all records from the right. If I'm doing a full outer, it means all records, and if I do a multiple table join, you're going to join records from multiple tables. So this is going to allow me to specify which table and the join condition. So if I'm selecting the name and phone number from people, I'm going to join the phone numbers where people ID and where people ID equals phone number ID. It's just a matter of how you're doing some of those components. I don't spend a lot of time on join in this class, predominantly because what you're going to be looking at is a little bit more simplified. You're going to have to be able to have some join statements in the group project, but I'll help you in that situation. If I'm looking at some other select components, again, you're looking at what you're specifying, where you're specifying it from, what conditions are you looking to meet, and how you're looking to see the results. How you're doing your group by, how you're doing your having, what you're doing in the overall, and then how you're managing your aggregate functions. You need to know these for the exam. You need to know that from an aggregate function perspective, you have average, you have count, you have max, you have min, you have sum, and you have count distinct. And this allows you to do all of your sorting, and by doing halving, it allows you to search the group by results. Here's a couple of good examples of the group by. So if I'm selecting all from contacts, I want to group by company. If I'm selecting counting, I'm doing group by. So it allows me to do a number of different components, and then I can do a group by and then a halving off of the group by. An order by allows you to get into a sorting component. Now, when we get into views, it's really helpful when you think of it as a virtual table. And we're going to create more views when we're doing Oracle and SQL Server over the next couple of classes. As I previously mentioned, views are a bit more of a snippet or a snapshot that gives you a virtual table from a select statement that you can then perform conditional expressions off of. So if I'm doing a create view, contact view, it's going to pull specific information off of a select statement to then be used for reporting or queries. Now that I'm mentioning queries, I want to make sure that we're looking at it from its basic form. So you're selecting attributes from a relation where conditions occur. The relations can be multiple or joined. The condition can be selection. And then you can have how you are showing your results. So if I'm doing a select all from product where category equals gadgets, and if this is the table that I'm dealing with, as you can see, the category equals gadgets in 2 of the records, and those 2 records are going to be what's showing up in my results. Take a good long look at this slide. This is very common in terms of what would the result be. So the question is, given this information and this SQL statement, what would the result be? Another example, select price name, product name, price, and manufacturer from product where price is greater than 100. You see in those situations we've got two items, a single touch and the multi-touch, and the query is again not displaying everything, just the product name, the price, and the manufacturer are part of the query. So just think of it from how I'm pulling the information and what the answer. So you've got your question and then you've got your answer. Essentially an input schema and an output schema when I'm looking at how I'm going to present the data and then how I'm going to show the results. Looking at the like operator again, it really comes back to the wildcard and using the percentage sign for any sequence of characters. So if I want to find all products where whose name mentioned gizmo, you're going to see the percentage sign both at the beginning and the end because it wants to have it where it contains. So think of it like and then your wildcards and the expression. So if I do a select distinct category from product versus a select category from product, if I run that off of that table, it'll eliminate the duplicates because just doing all will show the 2 categories for gadgets, but I really want to see that the only categories that we have are gadgets, photography, and household. Now, don't forget when we get into the topic of ordering, that ordering is ascending by default. So it's going to do things in ascending order unless you specify descending order. Anytime there's a tie, it's going to be broken by what you have as your attribute on the order by list. But again, order is always going to be ascending unless you specify descending. So if I'm going to do a select category from product and order by product name, what do you think the answer is going to be? Same thing, if I'm ordering the results, what I want you to do is pause this, take a look at this, and put together what you think the results would be, and then send me an email and let me know if you're right. So again, going into joins, if I'm going to connect 2 or more tables, if I've got these 2 tables from a product and a company perspective, what is the main connection that you see between them? It's pretty easy on this name. So you're going to have the company name in the company table is the manufacturer name in the product table. So you see Gizmo Works, Canon, and Hitachi. That's where you're going to do your join. So I'm going to do from product and company perspective. Let's say I want to find all products under $200 manufactured in Japan and return their name and prices. So I'm going to do a select product name and price, which are the two fields that I'm looking for, from both product and company, and then I'm specifying the where, which is giving me both information from the manufacturer table and the country table. So looking at this, what do you think the end result will be? It's going to pull the price, it's going to pull the canon information, and it's going to pull the country. So in this situation, it's only the single touch at $149.99. Another example, if I have a product name, price, category, manufacturer, and find all countries that manufacture some product in the gadgets category. This is what my SQL will look like, and what do you think the answer would be? What's the problem? What's the solution? Where is it getting pulled together? So what I want you to do is look at the table, look at the expression, look at the SQL. Find the names of people living in Seattle that brought some product in the gadgets category and the names of the stores they brought products from. Then look at the SQL and see how this is being done. So I'm doing this distinct because I want the distinct person, name, and store from the three tables that match the conditions applied. So let's take it at a higher level perspective here. When we're doing the queries, we're focusing on the select from and where. Now let's talk about an example since it's getting close to Halloween. And I know you seniors are going to be probably looking at something like this. If I'm using an example of a bar, and if I've got tables for beers, bars, drinkers, likes, sells, and frequents. Let's just say I want to show what beers are made by Anheuser-Busch. So select name from beers where manufacturer equals Anheuser-Busch. If I'm looking for a select all, it's going to give me all of the attributes where manufacturer equals Anheuser-Busch. Again, renaming. If I'm doing a select name, I'm doing that as, I'm renaming select as beer. So now name is going to come up as beer to show in the results that beer is Bud, Bud Light, and Michelob. Okay, you can get into values in your columns provided that you have it set up as a value and not as a text. So if your price field is set up with a value times 120, it'll allow you to display the price in yen if you're doing a conversion. Okay, just a couple other tips and tricks. For example, if I want to select the price from cells where the bar equals Joe's Bar and beer equals Bud, this is where I would look at making sure to understand that the SQL is case insensitive. You can write select and etc. in upper or lower case. It's only inside your single quotes that it's going to matter, because then it's going to look for something identical. So anytime you see the percentage sign, it stands for a string. The attribute like is a condition that's true if it matches a value. And here's an example. If I'm doing a multi-relation query, I'm going to be pulling information from multiple tables. So if I want to find the beers that the frequenters of Joe's Bar likes. Okay, so I've got two tables, likes and frequents. Sorry. And this is how I'm going to select beer from both the frequents and the likes table. So if I want to write some queries that find all customers who have a loan and an account or both, find all customers with a loan or an account, or find all customers with an account but no loan. This is how the SQL would look. Again, it's all about reading. So look at this SQL and then look at what it's trying to do. So if I show you select customer name from depositor, intersect with select customer name from borrower, it's going to find all customers who have both. Okay. Again, coming back to functions, we're looking at aggregate functions in the overall. You need to know these. Average is going to be the average value, minimum, the minimum value, maximum, the maximum value, sum, the sum of values, and count, the overall number of values. A good example for you, find the average account balance at the Perryridge Ranch. So average from balance, where account from account, where branch name equals Perryridge. Again, look at what it's trying to do, look at the SQL, match it. Select count from customer if I want to find the number of tuples in the customer relation. If I want to find the number of depositors in the bank. I'm going to show you SQL and ask you from a multiple choice to be able to say, okay, this SQL statement does X. Again, more examples going in and showing group by. This allows you to go outside of the aggregate function, and it needs to appear in the group by list. A good example of having, so select branch name and average balance from account, grouping by the branch name, having an average balance of greater than 1,200. It allows you to see what more complicated queries look like, but still keeping it where you can read the SQL and understand what it's trying to do. Finally, for this virtual lecture, I want to spend a minute talking about nested subqueries. So if you think about it hierarchically, I can put a query within a query. So when you hear me say a nested subquery, it's a query within a query, or nested within there. And with that, I'm going to end on the in construct. So if I want to find all customers who have both an account and a loan at the bank, this is what my SQL would look like. Find all customers who have a loan at the bank but do not have an account at that bank. This is what the SQL would look like. And we'll continue on shortly in terms of the remaining slides to go over an example query, where you'll have something that shows both a nested query, the sum construct, which we'll very lightly use, the all construct, which is not on the exam, and a great example from an exist construct. Thank you.